Hey, good morning, everybody. Welcome to our Cube and Rittman webinar. We're just going to wait a few minutes for folks to file in, and then we'll be getting started here probably 3 or 4 after the hour.
And folks, if you're joining right now, we're just waiting for people to roll on in. So we'll be started here in a couple minutes.
And Nathan, if you see Igor in the crowd, can you promote him to panelist?
Hey everyone, really happy to join you on this webinar. What an amazing group we have here.
All right. I guess we can go ahead and get started. About 4 after the hour. I don't want to waste anybody's time. Yeah, everybody. Really great to have you all here this morning or afternoon or wherever you're dialing in. Thank you for being here on the webinar with Cube and Rittman Analytics. Webinar today is how Rittman Analytics delivers the semantic layer today with Cube. And my name is Brian Bickle. I'm the head of partnerships here at Cube. And we've got Igor from our side, and I'll let Igor introduce himself. Igor, you're on mute.
Sorry folks, Zoom is hard. So yeah, hey everybody, really happy to be on this call. My name is Igor. I'm the head of developer relations here at Cube, and probably those of you who joined our previous events may remember me, but for those of you who are on this webinar as the first one of you, I wish you luck.
Yeah, and we're joined by Olivier and Lewis from Rittman. So Olivier, if you want to introduce yourself.
Yeah, hi everyone. Olivier, I'm CPO at Rittman Analytics. I've been doing analytics engineering for quite a few years now. Joined Rittman maybe 3 years ago. So yeah, and also run the Discussus project where I do a bunch of experimentation on analytics engineering, which kind of inspired some of those ideas here. So yeah, Lewis.
Very good. And I'm Lewis. So I'm Chief of Operations here at Rittman Analytics. I've been working with Cube for a long time. I'm a massive advocate, and it's very much in my wheelhouse. Aside from being a technical fanatic, I'm also a big fan of like linguistics and semantics, and the moves that Cube are making at the moment are really interesting, and can't wait to dive into them in this webinar.
Thanks. Yeah, thanks for the intros, guys. Before we get started, Cube does have a code of conduct for all of our webinars. So, our intention is to make sure that this is an open and welcoming environment. If you have any issues with this, or if you see any kind of situations where you feel like the code has been violated, we do want you to let us know. You can reach us at that conduct@cube.dev email address. And just quick notes, if you have any questions about the content today, you can type them in the Q&A section on Zoom, and we will get to them as we can. We have a couple of Q&A sections built into the webinar, so please feel free to send us those questions. All the demos that you see today are going to be presented using Cube Cloud, which you can get your own Cube Cloud account at our website, cube.dev. And after this event, the recording will be available at our events page, where it'll live forever. It'll end up in YouTube and all the places we post our videos. And after the event, we will send you all a post-event survey, and we would love it if you would give us some feedback. We want to make these events as useful as we can for all of you. And let's talk about what we will discuss today. Today, we're going to get through some content about how Rittman thinks about data platform engineering, and specifically how cloud semantic layers fit in, the product that the Cube builds. We're going to talk about what a semantic layer is. You've probably heard a lot in data Twitter and data LinkedIn about semantic layers, and maybe you have a lot of questions. So we're going to talk about how Cube provides that functionality. And then we're going to get into some deep dive demos, and then finally a Q&A section. But before that, as I mentioned to you before, I'm the head of partnerships here at Cube, and I do want to talk about one launch that we did recently. We've recently, as in yesterday, put out our Cube Partner Network, and this is our consulting partner program. So if anybody out there in the audience is from a consulting firm or is interested in that space, please check out our page. And if you're interested in joining the program, I'd love to speak with you. We have our friends at Rittman today, who I'm super happy to be on this webinar with, as they've been big advocates of Cube and have joined us in our inaugural class of consulting partners. So again, I can't say enough nice things about these guys. And if you need any help implementing modern data strategies or semantic layers, you should absolutely look up Rittman. And with my part out of the way, I'm going to hand things over to Olivier.
All right. Can I take over, though? I'd like to share my screen. Yeah.
Yeah, I stopped. You should be able to share now.
Okay. Give me a sec here. Okay. Minimize that. Move some bars around. All right. And where is that slideshow? There it is. All right, great. So again, thanks Igor and Brian for having us. We're pretty excited to come and talk about the semantic layer. It's something that, as Lewis just mentioned, we've been talking about it for such a long while. We've been experimenting with it. And yeah, so the reason why we wanted to do something with Cube and specifically talk about like building a semantic layer is, as Brian mentioned, there has been quite a lot of conversation around the semantic layer, what it is, what the value of it is. But we felt like there wasn't that much content about like how people are actually delivering a semantic layer. So we wanted to just contribute to that a little bit. So this is just based on our opinions, on our approach. It's evolving. Like, again, we're experimenting with it. So of course, like this is just our approach. We want to showcase that today. So yeah, so that's kind of the agenda. So we'll go through what is a semantic layer, the value of it, of course, but really how we build it and how we deliver it. We'll be doing live demos, so hopefully things will go well. But yes. All right, so let's start with like probably what you've already all read somewhere. What is the purpose of a semantic layer? Really, the semantic layer is just to derive meaning from your data. So you have raw data, you want to ask domain-specific questions on top of that data. and you wanted to return meaningful answers to those questions. So that is kind of like the high level purpose of it. Oops. So it superimposes an abstraction on top of your data to do to answer those questions. And to do that, there are a few components that are associated to the abstraction. So you have your domain-specific entities, and we'll go over examples afterwards. You have relationships between those entities. You have a bunch of attributes. They can be either keys, dimensions, measures, or metrics, as it's been quite a lot discussed lately. And there are descriptions of those entities and attributes. So why build a semantic layer? Well, the first thing is that you probably already have one. You already have raw data that you're bringing into your ETL process, and through that process, you're kind of transforming that data to be meaningful, so that you can ask business or domain-specific questions on top of it. So you probably have one, but then you can go always further with that, especially once you have a multiplication of data apps that are starting to consume from that same data warehouse, where all of those entities and those relationships are living. At this point, it's not enough to have a semantic layer that is just coupled to one BI tool, for example, but you need to have like a layer that is on its own. And that allows you to really interact with your data warehouse, but from multiple endpoints. So the value is really that as the multiplying data apps start interacting with your data, that this abstraction becomes like the unifier almost. It becomes a central point from where all queries go through. And so you can have consistent results when asking questions. Of course, it improves your collaboration and communication. Everybody's talking about that same abstraction. They're using it in the same way. So that means also faster query performance and development and simplified data governance because you can control who has access to which data. All right, so let's get into a simple abstraction. So this is kind of the example I will go through today. The abstraction is for product analytics. So what that means is that you probably have like an event tracking system in place that generates a bunch of raw data about the events that are happening on your product. Now that would be your raw data source. And then you probably have an ETL process on top of that that is already starting to build a bit of an abstraction on top of that. So you would have your events, but also you would have information about the users, you would have information about the sessions, and even those events, like there are multiple types of events, some of them might be transactions. And out of those entities, you can start asking questions, so doing analysis on top of that. So for example, lifetime value and journey and all of that good stuff. So again, like this is a really simple abstraction, but that's kind of the idea of where we're going with that. So our approach, again, like kind of re-saying what I was telling earlier, is that this is really based on our approach, like our opinions on engineering data platforms, which really optimize for scalability, flexibility, efficiency, and quality. So that still applies to semantic layer. And again, like this is really kind of not a new layer, but this is something that is evolving fast. So we're still forming an opinion on top of it. So the example that we'll go through for that abstraction that was showing. So as you can see, we have those event tracking. So this is data that is being generated in that example by Rudderstack. And it's being stored in BigQuery. And then we have an ETL process that is staging that data. And then we are building a product analytics data product. And then afterwards, we have that semantic layer, which sits in Cube, that then generates that abstraction from which all of those data apps can send their request to. As well, we have the orchestrator here. In our case, we're using Dagster to orchestrate that whole sequence so that once we have a semantic layer or the abstraction from your semantic layer defined, then that can always be delivered fresh so that data apps are always pointing to the same data, but the same data that has been refreshed at a scheduled interval. All right, so that's kind of what I just said. So I think that I need to go into demo. So here's my demo. So this is a very simple query, and I need to move that toolbar somewhere else. All right, let's try to do that. Okay, let's make sure that this works. Move that again. For some reason, this is bringing me outdated data. Let's make sure. Let's refresh that 1 second. Sorry about that. Superset has its own caching layer, and sometimes it doesn't want to pick up the latest values. So hopefully, all right, there it is. Okay, so I updated my semantic layer yesterday, and at that time we had 19 events that occurred on the 21st of March at 3 p.m. And so Superset is currently connected to my cube instance. So if I go into the playground of my cube instance, and I can rerun that query just to make sure that we're using the latest data. And again, like this is showing the same thing. So Superset is essentially pulling data from a pre-aggregation here, which has been built yesterday, which has been refreshed yesterday. So let's go into our Dagster instance. So this is just running locally, but essentially, and I will run that right now because it might take a little bit of time. Here. All right, so while that runs, you will be able to notice that those are the same layers that we were talking about here. So as you remember, we had those sources that are coming from Rudderstack. So those are the sources here, not connected directly to Rudderstack here, but that's something we could do through their API. This is where the ETL process is happening in dbt. So we are staging that data, and then we're doing a bunch of transformation to extract the entities. So that would be that layer here. And then we're building our very simple product analytics, which in this case is only like the product events. I didn't want to do something overly complicated. But we have one fact table, and it's for the events. And afterwards, it's refreshing my semantic layer with Cube, which lives in Cube, which is what's happening here. So let's see if that ran. That seems to be successful. So let's refresh that. All right, so it ran at 12:19. So if I look at Cube, there it is. So I can see that I'm in my pre-aggregations. So pre-aggregation is really something that I've defined where I'm essentially pre-aggregating a table of measures which can be sliced by dimensions and including time dimensions. So essentially what I've done here is that I built a pre-aggregation for, and I have my definition here, for the measure of count of web events, and it can be sliced by the event type. And this is my time dimension, it's hour. So that means that I now have a table that has been built with those parameters, so that whenever I receive a request that falls within that scope, then Cube, instead of querying BigQuery or my data warehouse directly, it will use the data that is in this pre-aggregation. All right, so that pre-aggregation has been rebuilt with success. Let's see if hopefully my data is updated. And it is. So that's the latest data that we received from last night, which makes sense because RudderStack we only updated once at the end of the day. So my data has been updated here. So that's in Cube. So it's the playground from Cube. Let's make sure that the BI tool that I use to interact with my Cube layer also has been updated. It has, so I now have data that is coming from last night. So yeah, this is looking good. And now I can go into Cube, look at the queries, and I'm not even sure, Igor, if I'm supposed to be showing that because he told me that this hasn't been even released, but I've noticed that their UI has changed this morning, which I'm excited about. But essentially what I'm seeing here is all the requests that came, that passed through Cube. So that was the latest request that came in from Superset. And as you can see, it queried for the kind of web events. And it was for that time frame here, and it was sliced by the hour. And if I go in it, I can see that it used this pre-aggregation. So it used the cache data from Cube to return the data. And that was the pre-aggregation that we have just refreshed with Dagster. Now, this part here is really the abstraction definition that lives in Cube. Now, that part, I won't go too much into the details because this is what Lewis will be covering. But really, like for the sake of our simple example, like you can see that we have a cube, which is really an entity, which is called events. And there is one measure that is defined for it, so one metric that is defined for it, and it's a simple one, this one, and all of the dimensions that we can use to slice that measure, and then we have that pre-aggregation. So this is really driving, like whenever requests are made in the playground or all of the data apps, it's really it's leveraging those definitions to then transform those requests into SQL queries that are being then sent to your data warehouse or the caching if it exists. And just one last point, and I know Igor will get into that as well, but those are all the APIs that are available to interact with that abstraction, so with that semantic layer. So in our case, for Superset, we only use the SQL API. So you only need to set those connections to interact with your cube definition, your cube semantic layer. Is there anything else afterwards? Let me see. So yeah, just to wrap things up, like really the cube, how it acts in our example is really the engine for the abstraction. So whenever requests are coming in, the requests are really interacting with all of the entities, their dimensions, their measures to form questions. Those questions then are being translated into SQL query, and those queries are either sent to your caching layer or either sent to your data warehouse. So, and again, like there's that suite of API endpoints, the playground really to kind of test out your abstraction. And we didn't get into that, but the access controls again are available for really fine tune like which users can interact with which data. And I think I'm passing that over to Yarman now.
That is amazing. Thanks for a fantastic demo, Olivier. And yeah, let me now jump in and talk a little bit in depth about some of the features that Cube provides. Since I believe audience now got interested in, after this amazing demo, how Cube plays with other tools in the stack that might be relevant to talk in depth about why Cube and about their layers that it contains. So initially, the whole idea of building a tool that would sit in between the data sources and the consumers, it all emerged because of the fantastic proliferation of their data sources and the data consumers that happen. So basically, oftentimes, currently, data engineers have to deal with not a single data warehouse, but multiple data sources. And I already saw a question about that was asked. So yeah, data integration, this is a big one. And also, which is even more important, end users are demanding to have the proper tools, the proper applications where they can explore the data, interact with data, get insights from it. And the connecting all this mass, connecting the data source, data consumers, this is a task we're solving. So our approach to solving that is by bringing a semantic layer in between, and Cube is an implementation of such a semantic layer. It contains four so-called layers: data modeling, access control, caching, and APIs. And they provide certain values. We'll dig into that deeper, but let me just show you a more high fidelity schema or diagram in which we can better understand what is the proper place of a semantic layer in your data pipeline, right? So the idea is to make sure that the data consumers, you can see them on the right, are hooked up to the APIs, and those APIs correspond to whatever the capabilities of the data consumers are. For your BI tools, well, you would probably like to use a SQL API, and whether if you're building embedded analytics on the front end, well, then probably GraphQL or REST API is the best choice. And on the other side, you will have your data warehouse where you consolidate and all your data with data transformation tools to which you ETL your data. And all that is governed and controlled by the data observability, discovery, and orchestration tools. So this is the place for Cube, and what Cube can provide are the following capabilities. Its data modeling layer is what implements those components of abstraction that Olivia just talked about. And the Cube terms, well, as funny as it may sound, these are cubes, views, joins, measures, and dimensions. But for those of you who are coming from Looker background, who might be familiar with that part of the world, well, you can think of their data modeling in Cube really like of data modeling in Looker, because the Cube models there are very similar by the syntax to LookML. But the beauty of the data modeling layer is that this is a single source of truth for a matter of definitions. So whatever you define there, that will be reused in all data consumers. This is one of the forms, one of the syntaxes in which you can define your data models. It uses YAML, which is one way that you can do that in Cube. The caching layer is one of the most powerful things that Cube has, and thanks Olivier for showing how you can externally trigger the refresh of those caches in Cube, right? But the way to think about that is that Cube provides you a way to fully control whatever would hit your upstream source database and whatever will be served directly from Cube. So you're really in control of the trade-off that you're able to make, whether you get sub-second latency, you get fast queries, or you get the queries at the speed or the performance that your data warehouse can provide, that's a trade-off that Cube puts you in control of. And that is implemented with the in-memory cache. Basically allows you to not go to the upstream data source when identical queries arrive, that their second, third, subsequent queries will be served with the memory cache. And pre-aggregations is a more long-term solution to caching that actually transforms and stores a version of data from a data warehouse in an intermediate representation, so-called rollups, and serves your queries from them. And yeah, you're in full control. Obviously, it's really simple to configure how your caching works, and in the most simplest scenario, you'll be just adding a few lines of YAML or JSON code to your data model. And this beautiful orange bolt on this slide just basically shows that even if you have to process a vast amount of data, possibly billions of rows in your data warehouse with pre-aggregations, that would be taken way less than a second. So this particular example query that's in the slide, it took just slightly more than 100 milliseconds. With regard to APIs, as I said, the beauty of semantic layer and beauty of Cube is that it is able to interact with any downstream tool that you may have. So for your BI tools like Tableau or Preset, Superset, or Power BI, what you would use, or for the data workspaces and notebooks, like Hex, DeepNote, or Jupyter, what you would do, you just connect the Cube SQL API, which is Postgres compliant. It means that if your BI tool, your data notebook, or whatever you have talks to Postgres, if it connects to Postgres, well, it will connect to Cube without any issues. And also, if you're building embedded analytics, if you want to connect your front-end app, well, the GraphQL API and REST API will get you covered. So since Cube is this single source of truth for method definitions, and those APIs are exposed by that source of truth, you get consistent results across all data consumers, regardless of which flavor of API you use. And yeah, as you already saw in a few slides, there is this Cube Playground where you can preview or debug your queries. So you can do this in the UI, or you can write it by hand, and you'll get consistent results. And here on the slide, you can see maybe one of the simplest queries that you can write with a SQL API or REST API. And it can get more complex and even more complex, but as you can probably see, the SQL API here, the query that you send to SQL API here is very much readable, and I would say very much in the form and shape that I would personally compose. So that was the intro into some of the layers that Cube has. And with that, I think we are ready to jump into Olivier's part with the practical considerations of implementing the semantic layer.
And thanks, Gal. And those are really like quick things I want to cover before I hand things off to Lewis. Let me share my screen again. But really, like, again, going back to that point that I'm on the wrong one. Okay, so going back to that point that defining, like, building a semantic layer, there are a lot of components in it, and there are a lot of choices. Like, it is based on opinions, and it's based on design principles and how your organization works. So there are a lot of choices that need to be made. So I wanted to just point those out, just a few of those. Just to kind of say that, like, we've made some choices, but like, you probably will do things differently. So of course, like, in terms of modeling, the semantic layer, what Igor was just showing, like how you actually define your cubes, your views, your pre-aggregations, and all of that. Like, it's a very flexible syntax that you have access to with Cube. So you kind of have like an opportunity to go a little bit wild here. That's not the approach that we've decided to adopt, and Lewis will kind of go over that. But, you know, like, I've seen different approaches here on how to use Cube. It can either be like a very simple replication of what you have in your data warehouse, or it can be like almost like how you would have views or in your data warehouse previously, but they would be exposed instead in Cube. So all that to say that the modeling syntax is very flexible again, so you kind of have like choices to be made here. The caching is the same idea. Of course, like Cube, just as Igor showed, like with the pre-aggregation it's very efficient. It's a very efficient way of caching your most common request. But the simplest approach would be to not have any caching at all. Or you could rely on your BI caching as well, just like I've shown with superset, like that is kind of causing issues sometimes. But regardless, like there are caching available elsewhere, or even like a client of ours is using BigQuery's BI engine to cache specific tables, which is a valid option as well. So caching is like another of those thing that you'll need to kind of like consider your options and see what is the best fit for your organization or your deployment. But yes, Cube does come with a great option for caching, but you do have options as well, other options. And the harvesting metadata, like I think that's an important topic, and that is, Lewis will cover a lot of it as well. But there is like your semantic layer is mostly metadata about your data. So it's really that abstraction is about like describing how you can query that data, like what that data is, like what their entities are, the relationships between those entities. So it's describing that data. But a lot of that metadata, that information already exists elsewhere. So it might be in your database metadata. It can be in your DBT manifest file. So there is an opportunity to kind of harvest that metadata to really sync the components from your data platform. And Lewis will show how Droughty is, Droughty, which is the open source tool that we have at Rittman, is using the database metadata to really accelerate building the abstraction on top of our data warehouse. And we've seen how people have been consuming the metadata from DBT jobs as well to really populate the abstraction. But metadata is really something that people should consider and really think about how you can really improve the deployment of your semantic layer by syncing with upstream components. So with that, I think I'm passing that over to Lewis now. Am I right?
You are. Yeah, fantastic. Okay, so thank you, Olivier. So what I'm going to be doing is I'm going to be running through a slightly like sort of like practitioner's deep dive into how we get to the finished article and how we get there incredibly quickly. So like something that we try and index towards is decreasing engineering overhead wherever possible and decreasing time to value. And our method of using Cube is really fantastic at doing that. So I'm just going to share my screen and I'm going to work through the items in the agenda that I want to address. So one thing that I want to do is I want to anchor this in actual business problems. Like what business problems are we solving through doing this? Because there are, you know, the industry is changing at the moment and there's been a shift through the breaking down of the monoliths within the modern data stack, but that breaking down of a monolith has introduced its own complexities, which brings their own problems to solve. So I'm going to help work through some of those here. I'm also going to describe what we're doing. I'm going to do that in two parts. I'm going to work through the conceptual side of things because, as everyone on this call is probably aware, you know, there's a degree of ambiguity about what it is exactly that a semantic layer does. It's perhaps not it's not something that hasn't existed before, but it's having a re-emergence, and that requires a bit of exposition. And then I'm going to just work through what tooling we're using to get there. I'm going to keep that quite brief. And then finally, what I'm going to do is I'm going to work through how quickly we can do this and accurately, because you don't want one to take away from the other. And then I'm going to give a bit of a live demo of how we actually develop. So what problems does this solve? So there are some fundamental issues in the way that data models exist in a lot of BI tools at the moment. And one of those is the sort of what I'm calling here the unidirectional data model. And to put that in plain terms, most SQL queries and most modeling starts with a select star from, and then a bunch of left, inner, or outer joins from there on after. And that introduces a problem. And that problem is the second point here, which is that, you know, if anyone's worked in Looker or something, a view or a connection of those things from a select star end up running out of road. And a prime example of this within the business is if you've got like an events table and users, and there are records in the events table that aren't in the users table or vice versa. And as everyone, well, as a lot of people in this call might be aware, models, if they're not organized in a way where there's a bunch of many to one left out of joins end up becoming really imperformant. And these two things together create the thing, which is a unidirectional data model. So it's just going from a select star down, and it means that it's an inflexible query. It's always catering to an angle of inquiry, whether it be from the user outwards or from the event outwards. And that doesn't scale particularly well. And it means that for business users, if they want to approach that, like a set of business questions from another angle, they then need another explorer in for them, which is an engineering overhead. And that is a problem to be solved. And it's something that we find that on a lot of our implementations of like BI implementations, you end up getting to a point where the data model ends up running out of road. Another problem to be solved is what I was alluding to when I was working through the agenda. And that's the sometimes poor integration between tooling within the modern data stack. So one of the advantages of tools within the modern data stack is there's one tool doing something really well, but they don't always harmonize perfectly. And they also sometimes require you to repeat yourself when you're handing over information between those two systems. A really good example of this is if you're developing in dbt and you want to reflect those changes within your semantic layer, whether it be LookML or Cube or TML for ThoughtSpot, you then need to duplicate that work and mirror it in the semantic layer. And that has two problems. One of them is engineering overhead, but the other one is a delta inevitably starts to emerge between those two systems. And you'll get the classic thing that you would have experienced within tools which hold a semantic layer is you go to query something and the upstream record can't be found because someone in the warehouse has renamed it or deleted it or changed it in some way. And then the end user gets this sort of pain moment where they can't retrieve the data. And it's that sort of disconnectedness that the modern data stack can sometimes bring forward. And it's something that we work incredibly hard to correct. And that's what I'm going to be talking about when I talk about Droughty. So that's another problem to be solved. Another problem is with all of the tools that you introduce when you're sort of like trying to build up, again, a modern data stack, you spend a lot of time building out infrastructure, but not an awful lot of time analyzing it. And I like to sort of like wind up the team internally, which is that when I was a quantitative analyst, one of the best tools I've ever used was Excel, because it meant that I could actually experiment with data freely and play around with it. And I didn't have to make loads of requests to get there. And I mean that obviously in jest, but there's a risk that with all of these tooling that you introduce, you just introduce more infrastructure instead of value. And again, that's something that we're going to be trying to solve in this webinar. Another one is systematic testing. So again, when we use Cube in combination with dbt, we impose primary key testing, referential integrity, all out of the box using Droughty. And finally, another problem is a lot of BI at the moment that doesn't have a good semantic layer deals primarily with ontologies. So like entities within a business. But a business question, the medium by which people get their data requires context and semantics in order for it to be properly comprehended. And a key differentiation there is that there are tools emerging within this industry which are bringing out semantic layers, but they're really metrics layers. They don't really yet have the ability to build out rich connections between your tables, your facts and dimensions and other entities, and they fall short of doing what they should be doing. And that's something that Cube does incredibly well. So they're the problems that I'm going to be addressing in this short time. So how do we do it? So we push forward what I'm calling a headless semantic layer. So people would have heard about headless BI, right? But there's a risk that you then move that engineering overhead into your semantic layer. So you need to go and write out all the code and everything else. And that's as much of a problem as having a huge engineering overhead in your BI layer. So we automatically generate all of our semantic layers. So our joins, our primary key definitions, our measures, they're inferred by the way that we model, right? So it's almost as if you've got an elastic physical model that grows and expands depending on the business question automatically. And that's key because really these things, it can be done. So why not? Why introduce that engineering overhead? So we try and make our semantics as headless as possible. And we also couple the semantic layer to the warehouse. And we use what I'm calling, and what we call here in Rittman semantic inference to do this automatically. And that what that means is that when you build out a data model, it has within it a bunch of meaning that, if done correctly, can be inferred. And all of the things that I'm saying to you right now, you're using inference to comprehend them, and you should be able to do the same thing with a data model. So we take that same philosophy that's sort of available within linguistics, and we impose it upon our physical models. We also use transitive joins. So Cube's unique in its market in as much as it's using transitive joins. And I'm going to linger on this a little bit when working through the demonstration. But what that basically means is that you can define a join many times, and when you generate the query, it will find an efficient path to return it to you. And that solves the issue of that unidirectional explore that you'd have in Looker. It means that you can ask a single data model different questions in different ways, and it will answer it differently. And that's huge. It gives you a flexible data model that is, like malleable, depending on the person who's asking the question. We also use symmetric aggregates, so within Cube, and that's the classic thing of it uses the primary key of the table you're using to roll metrics up and down accordingly, and that's incredibly important because it means, again, it provides you with flexibility. And we also use warehouse metadata to enrich the meaning of our entities. So in Droughty, and actually a few other people are doing this at the moment, we use things like ChatGPT to automatically enrich the data on the fly. And we also use semi-supervised machine learning models to resolve entities. And I'm going to walk you through all of that. So that's how we do it. And in the tooling we use to do that is dbt. We use a data warehouse, whether it be Snowflake, Fireball, BigQuery, etc. We use Droughty, XHeart as well, and that's open source, and anyone can go and use that free of charge. And we use Cube. So this is what the architecture broadly looks like. So we have a bunch of models for sources that extend beyond Harvest and Jira, but I'm using them here, and things like RudderStack. And then they're semantically interpretable in an automated way. And then we run an entity resolution module, which brings those things together. And say if you've got like it would canonicalize entities, for example. So if you've got entities within Jira and Harvest, it will find out the ones that are correct. So if you've got Lewis in one system, Lewis in another system, but it's spelt slightly differently, or we've got different emails or something, it will use that machine learning model to bring them together, and then automatically generates the joins for them and puts that into Cube. And this is what we'll be working through in the CLI. And it leads to a question, how quickly can we do this? So in order for us to build a warehouse using dbt depths and to run it, and this is a large warehouse with like joins and unions and like relatively high volumes of data, then to generate the semantic layer and resolve the entities, we can do that in under a minute. I timed it yesterday, 51 seconds. So again, all of those problems that I was talking about above, one of the biggest ones is engineering overhead and duplication of workload. And that's a sort of visual example of how quick we can do this. So very quickly, what I'm going to do is work through the actual development workflow. Unfortunately, it is very quickly, and I'll be able to do it in moments. So what we do is I've got a demonstration here. So by running these series of commands, what it will do is it will start deploying our packages, which are developed in a way where they work with semantic inference, and it will start deploying them and running them. So if I scroll up here whilst it's doing it, so I can do it a little bit quicker, you can see here that it's pulling in the sources. It'll then run the model and build the warehouse. Now, in theory, if anyone in this room had access to these deployments, they'd be able to do it as quickly. And then it wouldn't matter about the underlying data because of the entity resolution module, which you can see is running here, where it's initializing the entity resolution. So in scanning through all of that data that is unique to your company and finding the records that match, and then using a semi-supervised machine learning model, it's clustering them together so that they harmonize well, and then job done. So, and you can see here, it builds on the fly seamlessly, and it's repeatable as well. So if you were to add packages to this, it'd be equally as easy. So it's incredibly scalable. The output of this, if I quickly go here, is a bunch of semantic files. Now, when it's run that model, there's some key stuff going on here. So you can see it goes and infers the relationships and the cardinality between tables. So it can infer whether records have many relationships or they belong to them. And again, that helps with helping Cube to roll up and roll down measures. it's also doing some of the bits here. So you can see here that it's automatically inferring the joins between tables, and it's doing so many times. And that allows it to have bi-directional query patterns. And it does it incredibly quickly. This is all automatically generated. And then it will assign things like primary keys as well. And then again, that helps enforce consistency upon the semantic layer. And it's also bringing through those descriptions that have been automatically generated as well. So you're getting really rich data on the fly. And it takes what would perhaps take a team of engineers many weeks or months to develop, and takes it into a momentary process. And you can see it's generating on the fly now, and it's just regenerated. It's incredibly quick. It's also output here that entity resolution module, which is that semi-supervised machine learning entity resolution module there. So that's also bringing not only the semantics of your business together, but it's also then making them cohesive and harmonizing well. And that's job done. It's really as quick as that. And now if we go into Cube itself, I can start showcasing the benefit of that. So here are those automatically generated semantic models in here. And really, we ignore this. We don't spend any time writing code in this area. It's all inferred by the way that we work, and then it can do some pretty incredible stuff. So here we've got, so first of all, if I start with entity resolution, using the power of Cube, you can see here that spun up incredibly quickly, and we've got companies, and this is I've obfuscated the names of companies we work with, but this has taken companies from different systems and brought them together automatically and resolved the entities and started doing some interesting stuff. So they're reconciled here. And you can see that it actually starts to generate some pretty complex SQL with very little engineering overhead. And as the rest of the team was saying, you could then put this into a data app. You could get the React code of a JSON query of a GraphQL and put that in your app. You can also start doing some really interesting analysis immediately. So here we're looking at our performance, how good are we at story pointing across those projects? And if we wanted to expand the scope of our inquiry, we can then bring that through here and run it. And you see that's lightning fast as well. And then we can see that, the code, the generated SQL is starting to really expand. There's a lot of work that's happening free of charge here. If you had to go to someone in your business and say, write me that piece of SQL, it might take them a day or 2 days, and it's instantaneous, and it adds up because of all of the automated testing patterns that go in there as well. And just to expand on that a little bit further, because I'm conscious that we're running out of time, here's another example of looking at how efficient we are at story pointing against our timesheet hours. So as a consultancy, we've got actionable insights that is completely deployable. Anyone on this call could run that command and have this in their hands. And it's only really through using a tool like Cube and technology like Droughty where this is comfortable in this time period. And the beautiful thing about it is, because it's relatively elastic, you could bring in another source, resolve the entities, generate the semantic layer, and away you go. So if you're looking at rapidly deployable, complex, scalable models, in my opinion, there's almost no more competitive way of doing it than that. And the beautiful thing about working with Cube is, as you've seen on this call, like really close-knit team, they're so receptive to help out. And the sort of pièce de résistance here is, you could run pre-aggregates and it would be lightning fast for an end user as well. So, from a developer, frictionless development, and then for the end user, instant querying. So I'm incredibly excited. I think that this is probably the way that modeling should move. And there's an unanswered question here, which is that you've got traditional dimensional modeling and traditional BI, and I don't think it works amazingly. But this approach does. So yeah, it's an exciting time. So 5 minutes left. I'm conscious that we want some QA. So I could talk for another hour on that. So maybe there'll be a round 2 or something, but let's hand it over to the participants and see if there's something that we can help them with perhaps. Unless Brian and the rest of the team, you've got thoughts otherwise.
Yeah, thanks, Lewis. We really appreciate all the kind words. And as Lewis said, we've got 5 more minutes here on the webinar runtime. So if you have any questions, please fire them over in the QA. We're happy to stay on and answer those. And if there's anything we can tell you more about, we're happy to do it.
Yeah, and while we're waiting for the questions to come, I can briefly talk maybe about the one that was already asked and answered, because I think it is somewhat relevant to the conversation that we have at this webinar, right? So, in short, the question was about working with somewhat semi-structured approach to storing and accessing the data, like if there is a data in a SQL database and there is data somewhere else. So how do we hook up the semantic layer to that one? So I would say that probably the most battle-proven approach would be to actually consolidate all the data in the SQL-enabled data sources, right? So in a database, in a data warehouse, something that maybe a query engine like REST or Athena can talk to. And then surely you can put Cube on top of that, right? And have Cube read data through the query engine or directly from multiple data sources, which are SQL enabled. That is possible as well. And then you can build a data model and you can deliver the data to the data consumers. So not really sure which GraphQL enabled database was meant there. I know a few. But maybe the most robust approach would be to actually ETL the data from that particular database to a data warehouse and go from there. Oh, interesting. Still no questions. Oh, they're coming.
Yeah, we do have one. Yeah, I can read this for you, Igor, and I'll let you answer this. James Maldonado asks, how do you model hierarchical or recursive queries in Cube? I think we have this pattern, actually, don't we? Listed somewhere in the recipes, maybe?
I can't say that I kind of immediately grasped what that particular hierarchical recursive thing is about. But if the thing, well, so probably some proper clarification might help us all here. But the thing that I want to share is a response to that. If you want to drill down to some query, that it is easy as just extending the query that you have with some additional dimensions. So if that what was meant, then it's just as simple as, slightly modifying your query. If it's not, well, I'm happy to review the clarified version.
Yeah, James, if we didn't get your question answered, you can connect with us by email. We're happy to answer it.
Actually, maybe a better way to reconnect with us, and by us I mean not only myself or you, Brian, but also Lewis and Olivier, is to join Cube's Slack community. Well, it's slack.cube.dev. It contains thousands of data practitioners, and they're very active there. Well, we are all very active there. So the best way to get your question answered is just to reach out there. Okay, this is probably the answer to the previous one. And while I'm not 100% sure what I can digest from that is that surely the data model definitions in Cube, they, as Olivier mentioned, they should reflect kind of the business side of things, be semantic to what you want to query, not 100, not obliged to reflect what you have in your data warehouse. You can define your cubes however you like, with even these complex SQL expressions.
You have, one more question just came in, Igor, if you want to pick that one up.
The question's about giving the power to user to build a dynamic table of chart. Is it possible with Cube? Surely yeah. So basically, a dynamic table or chart would probably depend on some parameters that that particular end user would like to pass to Cube through the API, right? So there are a couple of ways that you can implement that. So the most straightforward way is to be actually passing parameters with the query, which is possible with Cube. It is this kind of set of parameters is called the security context, and well, you can just pack this additional values on your front end if you're dealing with a SQL or GraphQL API, or with a SQL query if you're working with a SQL API and pass it to Cube, and then those will be accounted for when the SQL will be generated for the upstream data source. And also, which is even more exciting, Cube supports the dynamic data model creation, which means you're able to actually create your data model on the fly or adapt it to some things happening in the external world. So basically meaning your data representation, be it a dynamic table or chart, it will reflect a dynamic model underneath, right? So you're able to custom tailor it to each user, to each person, to each company. If you're building your app in a multi-tenant environment, this is also possible. So yeah, sure. The short answer is sure. And there's another one. I'll probably read it myself as well. So the question is whether Cube has a capability like Looker aggregate awareness. Does Cube compare in this respect to DBT transform? So again, the shortest answer is sure, yes. And what you would describe as Looker aggregate awareness is known in Cube terms as just Cube's pre-aggregations, right? And Cube is able to understand by the shape of the query that you're running against any API that Cube has, whether that query can be accelerated with the pre-aggregations. And if it can, well, there is some not that straightforward way to resolve that. It's fully described in the docs. So, but if Cube understands that the data stored in pre-aggregations can be used to serve the query, it will serve it from pre-aggregations. If by some reason, like maybe having your time dimension aggregated over a different granularity that makes it impossible to serve the data from pre-aggs, then Cube would just hit your upstream data source. And if that's not what's desired, we also can control it as well, and just forbid those queries which are not hitting aggregations to hit the upstream data source. So you have full control there. And probably the last one, right? So we are over time. So the last question here, and again, I'll read it myself. Oh, okay, we don't have any. Right, probably that's it then.
Yeah, I think that's it. We're a little over time, and yeah, we've got a couple good questions in there. So, once again, I'd like to thank everybody for joining us, and really, really big round of applause for the Rittman team. Thanks for coming through, and thanks for being excited about Cube. So we're happy to have you here. Thanks, everybody.
Cheers.
Yeah, it was amazing.
Cheers.
Thank you.
Bye.